Anyway, thank you to be here today. Let's talk more about persistence layer. Is one topic that I love so much because there is a huge number and amount of challenge that I need to face it, and usually it's more complicated than the application side. So today I will cover a little bit about mastering Java persistence layer and how to achieve success, especially if you are a senior software engineer or an architect. Okay, so that's me. My name is Otavio Santana. Right now, I do live in Portugal. I had some opportunity to go nearby. Cologne is a lovely place. I learned a few words like no, Guten Morgen, no, Guten Morgen, Afashola, and Dankeschön. And that's all my German. Sorry for that. So I will keep in English, but it could be worse. I could speak in Portuguese anyway, so nobody will understand me. Oh, not okay. I could speak in Portuguese because at least I have 3 people who can understand me. But anyway, I will keep in English. And okay, as usual, the first question that we start is why. Why should we care about database nowadays? Why this is super important to us? And as usual, I do love a lot of history, philosophy, and this kind of thing that doesn't make sense for everybody, but for some random reason, I love it. And database goes beyond us as software engineer. The main goal of database is to endure knowledge through the humankind. Yes, you can think more about database as a modern cave or temple because the goal is still the same. Retrieve, delete, update, and read information from somewhere. Of course, with caves, it was not efficient enough, but right now with database, as you can see, we have more efficiency, and right now we have machine readings, read that information for us. So yes, we started with caves, then we moved to temples and churches and then libraries to finally have the dream of distributed database. Okay, I guess it is enough of history for today. So Otavio, let's talk about software engineer nowadays. So why we care about database in my applications, right? And basically, every time that we talk about modern applications, we talk about microservice. And we talk about distributed database. We talk about distributed application. That means immutability as much as possible. But where the state of my user is, where the state of my stock, my items are. So basically, I put the state inside my database. So basically, the database is where I put the state of my application, the state of my user, state of my price, a state of everything around my system. And this place is also where I put my current opportunity. For example, I handle with e-commerce. For sure, I need to put the price, I need to put the items, I need to check the items left inside my system. And for future is where my opportunities comes from. For example, I have a case in Brazil where we did a VIP card, a black card, in the bank, in the finance, and then we read those information and then realized that a lot of our clients enjoy wine. And based on that systems, we decided to create a winery. And this winery was the biggest in Latin America for 3 months consecutive. So the state of my application, the current opportunities, and of course the future, because I can read and see new opportunities comes from that data. But unfortunately, with this huge importance of database, we still have a huge amount of lags. So we're still missing several maturity models. For example, who is familiar with the glory of rest? Who have heard about GlobalREST? So GlobalREST is a maturity model for modern applications to use REST, where we have a couple stages, starting from scratch and move on to hey to us. We also have a couple of maturity models from application side. However, we still have a few on the database side. With database, we also do have a huge amount of paradigms. So I guess the majority of you guys are Java developers, so in majority of your time you are doing objects and sometimes some functional. But with database, we do have relational, we do have key value, we do have value column, we do have time series, and so on. So we do have a huge amount of paradigms that we handle today every single time. And guess what? We also have a huge amount of flavors in our enterprise stack. This data comes from last year, Stack Overflow survey. And as you can see, we do have a huge amount of different databases that are using in production right now. The most popular is PostgreSQL by Stack Overflow. However, we also handle MongoDB. That is not a relational database. It's a document type from NoSQL database. We also have Redis, that is a key value database of NoSQL type, and so on. Right now, we are facing several paradigms to handle with our enterprise application, our enterprise architecture. So it's not simple like that. And let's be unfair, because when talk about database, we need to put that in our mind. Usually, when you handle with modeling, is usually the first thing that we do. And at that time of development, we don't have enough information, or the product is not mature enough. That means probably we're gonna to refactor in this code soon for some reason, for rename the table, for include some information. And in the code side, it's just you, the IDE, and the refactoring button. But when talk about database, and on the other hand, we need to do the migration stuff. So we need to move our data to a new form, doing the migration stuff, and so on. So usually it's more headache, usually it's more challenge when talk about database sides. Beyond that, we need to face, as we handle with evolutionary architecture in the application side, that means we need to be ready for the change, because change is going to happen every single time, every single day. We also need to be ready to change in the data size. That means upgrading the database, moving the database to another place, migrating the database to another cloud provider, and so on. So we do have a huge amount of unfair when we compare to application side. And even with that several challenges, we still handle with soft architecture. Right? So I guess the majority of you are familiar with software architecture principles. This one here is my favorite book for who is starting to understand better around software architecture. The Fundamentals of Software Architecture by Mark Richard and Neil Ford. And this book brings two basic rules around software architecture. The first one is everything in software is a trade-off. We need to understand, analyze, and then take the decision to understand each one is the best for you on each case. And the second one is the why. The reason to do something is more important than the how. Okay, so the why is way more important than the how. So it doesn't matter if you're gonna use Python, Java, GraalVM. The main point is achieve the results of your business. Okay? So I mentioned the two rules around software architecture, and of course I need to say how to achieve success when talk about software architecture. And I can put that in 3 points. The first one, of course, is make the business people happy, and happier and happier. So the unique way to understand if you are doing a good job as software architecture is checking the business. So, am I doing a good job? Is the business wealth enough? The second one is isolation. Of course, I want to use technology all the time, but I need to protect my business from my technology itself. And what does that mean? Of course, I want to use Cassandra, but my user does not need to know about that. That means it does not make sense to receive a Cassandra exception on my screen. Of course, I don't want to see that kind of thing. I want to see a regular error message and super friendly error message. To the business, they don't care about the technology that you're going to use. They care about to achieve success. And the third one is once you choose a specific database like Cassandra, MongoDB, Redis, whatever, take advantage of that choice. Okay, so if you're going to use Cassandra, let's explore Cassandra query language. Let's explore the consistency level inside Cassandra. Let's work with Redis. So let's explore the structure that I do have in Redis. And let's search the search engine that I do have there, and so on. So business, make the business happy, understand the business. Indeed, there is a report from Forbes 2 years ago that said that the majority or the biggest issue with business in technology is the technology don't achieve what the client is waiting for. So that's still the biggest mistake that still doing even nowadays. Said that, I'm talking about, okay, the why is more important than how. And how to achieve success inside our application. Of course, understand better the huge amount of flavors that we do have close to us. Of course, we can explore more database solutions instead of use only a unique database. If you only know relational database, you're gonna put this database for everything. It's natural, right? It is the instrument law by Maslow. It's like a hammer. If I only know the hammer, everything becomes a nail, right? And for that reason, we do have the polyglot persistence idea. The main goal of the polyglot persistence is to understand how, why, and what use does a specific database. If you take, for example, a person who is polyglot is a person who is capable to adapt in several areas. Take, for example, Elder Moraes, who is here, close to me. So he is capable to speak Portuguese. That means he can go to Brazil and speak clearly in Portuguese. He speaks Spanish. So he can go to Spain and, of course, the whole Latin America. And finally, he can speak English. This way, he can stay here and do his presentation, guess tomorrow, about his talk. Okay? So a polyglot person is a person capable to adapt in several environments. And that's happened exactly with the database. A polyglot persistence is a persistence that's capable to adapt to several and different structure. It's capable to adapt in several situations. I will cover quickly with NoSQL database because I'm assuming that relational database is pretty similar for everybody. Okay? So I will cover only 4 different types. In relational database, we do have a standards, the SQL standard. And on the other hand, we don't have this kind of thing in the NoSQL side. We define NoSQL database by the structure that is storage in the database. And those 4 are the most common structure that we do have in the market right now. So wide column, key value, graph, and document. However, there are more coming. For example, there is time series database, there is multi-value database, and right now we do have the AI integrated with the database. So right now we do have over 200 database implementations. Going quickly to the NoSQL database types that I'm going to talk today. So the key value, the main goal here is to return information by the key and then return the whole information by value. If you are a Java developer, it's pretty similar to a map. So give the key, I'm gonna return the value, and so on. Then the most popular implementation that we do have with key value is Redis. So here we do have some success case with Redis. So I can use Redis for caching some information, for session management, precisely because mostly of the time that we handle with Redis and cache, we do have a unique ID for a user in the session, for example, the nickname and so on, the real-time analytics information, and finally to pub/sub messaging. So you can use Redis for those cases and it will be fine and fun for you. Here, I put the do and don'ts with Redis database. I go here quickly with those. So, of course, once we talk about a key value database, you can explore a super simple schema and explore the keys, of course, because you don't have another option, by the way. Use the concept of keys, operating and batching with this database. And of course, about the don'ts, there is no joins. Why I said that? Because it is still the biggest mistake when people goes to NoSQL database. People still trying to do joins even in key value database. Okay, so most of the time that I go, I'm independent consultant. Most of the time that I check the database because there is some performance issues, the majority of the cases are related to modeling. Okay, here we do have the structure of scalability with Redis. As you can see here, I do have the client who's gonna do a request. Redis works as the master slave structure or primary replica structure, where the primary is in charge to write information and then duplicate that information to the replica. And the replica is the one who's in charge to read that information. So I do a request, it's gonna do a hash. Based on that hash, I go to a specific area or data center. And based on that, I will check. So if I'm gonna write, I will write in my master or primary. If I'm gonna read, I'm gonna use one of those replicas. Okay? It's a quickly overview of course, scalability with Redis. As you can see, Redis implement for you the patching. So this way, I don't need to have the whole information in a single cluster, so I can share between those databases. So I have my key, generate the hash, and then go to the slot number 0, and then the second one, and then the third one. Then we do have the wide column structure. So the wide column structure is pretty similar to key value. However, with a tiny difference. Because with key value, I have the key and a huge amount of information as value. But with wide column, I take a small piece of that information that we call columns. So as you can see here, you can see that I do have the key and then a small piece of information called columns. So I have Apollo, my key, and then I can return, of course, the whole structure or a small piece. So dirty, color, Aphrodite, and you can see two things here. The first one is I still playing God of War. Don't ask me why, but still enjoy this game. And then right now I'm capable to return the information that I want. So if I want to return just the color, I can do it for it. That's a little bit opposite that I did with MongoDB, for example, or with Redis, for example. When talk about wide column, we do have okay, is returned, but it's become red, 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 red. So we do have the Apache Cassandra as solution. As you can see here, we do have several user case with Apache Cassandra. So online retail, social media analytics, real-time analytics, and logging and monitoring with Cassandra. There is another case. For example, you can use Cassandra to combine with event-driven design, where you can define the TTL of that information or the time to leave. For example, imagine that we want to process some finance information and you need to have this information for maximum of 7 days. You can persist that information, define that as 7 days, and after that, the information will disappear automatically for you using the Cassandra TTL. Okay? As usual, some do and don't with Apache Cassandra. Naturally, the mistake number one is normalization. Avoid that. Explore the denormalization way. That means use the Cassandra the way that you want to read that information. You're going to duplicate a lot of information. It is fine if you do that way. In Cassandra, we do have secondary index. However, pay attention with that. So what is secondary index in Cassandra? The majority of the time, you're going to search by ID. However, if you activate the secondary index, you can search by this information as well. But there is a performance issue if you put all the fields as secondary index. Okay? So my advice for you is avoid as much as possible. So you can use, remember, of course, you can put a huge amount of family of columns, but pay attention to the numbers. So as much information you put in the columns, as much information you're going to retrieve eventually. So it might be take time if you put a lot of information or have information inside your column. Here we do have a sample of scalability with Cassandra. Right now, what I do have, instead of have a primary and replica structure, Cassandra provides a massless structure. That means every node can read and write information. Here is a client doing a request. At this first point, the first node that received that request become a node coordinator who will coordinate the response for you. For in this case here, imagine that I do have 2 data centers and my consistency request, my consistency level is 3. That means it's gonna run for 3 node instance, verify the latest information that they do have, and then return to the client. And of course, I can do it every data center or a single data center. The point here is this request was in the number 10. The next one might be 11. The next one might be 12, and so on. So it's usually a road robin strategy to handle with Cassandra. The third one that I will cover today is documents, where we do have the structure that looks like XML or JSON file. This one here, we do have more flexibility to search information. So instead of only be capable to search by ID, you can search by ID, name, and other fields. With this document, we also can do a sub-document structure. That means I can put documents inside documents. And how awesome is that? So the most popular one is MongoDB, where we do have several success cases like content management, catalog management, mobile applications, especially because there is no conversions between your application and the database because MongoDB handles with JSON. And you can keep the structure almost the same. And several social media platforms. So you can use MongoDB for those cases and it will be fine. So as usual, they do and don't with MongoDB. The first one is explore embeddable documents. Instead of doing joins, it's okay if you duplicate it and put the whole information that you're going to read in a single document. Design around case and around queries. You can employ queries or index more easily than with Cassandra. You can normalize. It's more okay if you do that in MongoDB than in Cassandra or Redis. And you do have a huge flexibility with MongoDB than the previous database types. Of course, if you do a lot, that means it becomes heavy with a lot of information. Pay attention on that. And as usual, if you put 1 terabyte in a single document, you need to retrieve that 1 terabyte in a single document. Please avoid that. The cluster structure with MongoDB. This one here provides a pretty similar structure that we do have with Redis. So key value to read or write. Again, to read, I'm gonna use my replicas or my secondary nodes, and to write, I'm gonna use my primary node where it will write and then replicate information to my replicas. And of course, what happens if I do have a huge amount of information? You can sharding your information with MongoDB. That means you don't need to have the whole information in a single point. So I here have the shard A, shard B, shard C. So based on the hash of my ID, I can search information that I'm looking for. But hey, Otavio, but what happens if I don't do query by ID? Yes, it's a nightmare because I need to search by 3 different data centers sometimes. The last one that I'm gonna cover here quickly to introduce you the power of capabilities of NoSQL database, and of course the polyglot persistence philosophy is a graph database. With graph database, you can have relationships. I mean, even deeper than with relationship itself. For example, with graph database, I do have directions. Take this sample here. So I have 3 nodes, Apollo, Ares, and Kratos, and I do have directions. Apollo was killed by Kratos, and Kratos killed Apollo. So I do have directions to my relationships. Think about recommendations. Think about friendships. Think about relationships. So I can recommend people because it's natural for us as humans. Just because I know Neymar or Cristiano Ronaldo, it doesn't mean that they know me. So this popularity means directions. And you can also put properties inside my relationship as well. So it's awesome to understand that. You can do queries, for example, by friendships, things like that, using this kind of thing. So using graph. I don't know how many of you are familiar with friendships. I don't. I'm nerd, of course. But the primary is I need to know the person and the person needs to know me. So I can put that relationship with graph, but I cannot do it easily, at least with relational database. Okay? As usual, with graph database, you can explore and embrace relationship even deeper than relational database. Of course, you can do transversal path. You can navigate with this graph database much easily doing that. So, as usual, avoid joins. We are not talking about relational database anymore. Of course, every time that we put several properties, directions, that means use efforts to do these queries and navigate through this path. Okay. Here we do have several cases with Neo4j, social network recommendation engine, fraud detections. This one I worked in the finance and network analysis because I can define properties, relationship, directions, and so on. So the Neo4j is amazing and can solve you on those cases. Okay, Neo4j works as pretty similar as Redis and MongoDB. So leader and read replica is pretty similar to primary and master slave and so on. So just change the terminology. And okay, I talk about the different kind of NoSQL database, the capability that you can do with that, why I can explore, take advantage, especially to my business. But as I said, when talk about soft architecture, everything is a trade-off, right? That means, okay, I can go to key value where I do have a huge scalability. The majority of the key values gonna work mostly with memory only, but I lost flexibility. And what do I mean about flexibility in this case? I'm talking about the possibility to do queries beyond the key. With key value, a majority of the time, I only can do query by the key, not anything else. Okay? Okay, I explained more about NoSQL, database, polyglot persistence, and how about application, right? I mean, we are software engineers. We are missing software, but no anymore. So let's talk more about this huge fight that we do have inside our organizations. the real civil war between us and the DBA. So in one side, we do have our applications shining, doing what the business requirement needs. And on the other side, we do have the DBA fight for us because we try to change every single time the database. And that's happened first because we are doing code in different paradigms that we do have inside our database. So take here, for example, we do have our application that in majority of the time are oriented. And the most popular case here is relational database where I do have my relationship. So my application does not speak my database language. And that's happened with my mismatch. And that's consumed a lot of memory. That's consumed a lot of process. Because I need to translate what my application is doing to what my database is doing. For example, here, with my application, I do have polymorphisms. I do have encapsulations. I do have different types. I do have inheritance. However, my database has no idea about any kind of this. So in my database, I might have normalization, denormalizations, and any kind of different structure that you can use. There is a single exception that is Eclipse Store, where you can use exactly your Java structure to the database and everything gonna be super fine with that. So to decrease the complexity, we do have patterns with database. We do have Java patterns to make our life easier when you go to the application side. So I will enumerate, of course, only 6. So driver, data mapper, data access object, active record, repository, and data transfer object. Those here have a balance between the proximity. So there are someone here, some patterns that are close to the database. That means it will go to direction of database-oriented programming style. And there are others that are going more close to the application itself. That means going more close to the object-oriented programming style. Okay? For the one that is close to the database, they will follow the principle of data-oriented programming. So the code need to expose data all the time. Forget about behavior. Let's expose data. Representing that with generic data structure, lets you treat data or any circumstance as immutable. And last step is separating data schema from data representation. And on the other hand, and another extreme, we do have object that does the opposite. So the main goal of objects by Clean Code and by Robert R. Martin is expose behavior to hide data. Is to work with abstractions and explore as much as possible polymorphisms. So we do have two extremes. One that want to expose data, another one that want to hide data, one that want to use abstractions, and another one that wants to use data as immutable. So I will go quickly over those patterns. The first one that we're going to cover is the one close to the database itself. That is the driver. Mostly of you are it's fine? Okay, it's working, hopefully. So we do have the JDBC that must be familiar for everybody, where you can treat those information as immutable. So we do have here the select star from person, and as you can see, I'm returning the whole information and get information. The good points, I have a huge code flexibility with these patterns. So I don't have a predefined structure here. So I'm returning the ID, the name, the birthday, city, and city, and so on. However, if I need to convert that to my business, I need to do a lot of work. And sometimes I need to put these layers in middle, and I need to do it manually. And of course, it is not great. To decrease that complexity in our side, of course, we do have the data mapper, where the main goal is to convert or translate it to another layer. So I do have my database. I need to convert that to my application. I can do it manually, for example, Spring JDBC, or I can do that by annotation using Hibernate, Eclipse General SQL, and so on. The point here is I centralize the mapper responsibility in a single place, but I start to facing the mismatch impedance between two different paradigms. And that, trust me, costs a lot of power computing consuming. Then we do have the data access object, where beyond the mapper, I will centralize the database operations. As you can see here, I do have the insert, update, delete, and insert, update, and get out. So I centralize the data operation, but the mismatch impedance is start to increase even more. For example, if I'm using Hibernate, I might use inheritance annotation. That means the Hibernate need to translate that to my database. I also do have a active record patterns. That's much familiar with who is familiar with Ruby, but it's become a little bit more popular because Quarkus are using right now. The idea is I can give superpower to my entity right now. So I have my person entity where I extend the Panache entity, and right now my person is capable to do database operations. But with great power, we do have a U responsibility. In that case, we are breaking the solid principle because my entity right now can do also the database operation. If that's right, if that's wrong, what matters is your context. Remember, the why, the reason for do that is more important than how. So if it makes sense for your business on that context, you can write an active decision record and explain the reason that you take that decision. Finally, the one that's super far from the database and super close to the application itself, that is our repository pattern. As you can see, using a good sample here, I do have my personal repository that extends my whatever repository, and then I can do everything like magically with this framework, for example. As you can see, I'm doing the repository save, and I have no idea what does that mean for me. So I don't know if you're gonna insert, I don't know if you're gonna update, because this repository is gonna take everything on their side like a magic, right? So I'm far from the domain, and I'm super domain centric. Oh, sorry, I'm far from the database, and I'm super domain centric. As usual, everything has a trade-off, of course. If I decide to go to the repository, naturally someone is doing the data access object, someone is doing the mapper. That means I'm putting several layers. That's why I become far from the database. And on the other hand, if I don't do that, I can have a fat client with several layers in a single place. It might be more harder to maintain this kind of code. Please pay attention to that. As usual, layers are amazing if you are using properly. So as much layer you do have, as much layer you're gonna have as a headache. And of course, pay attention with that. The same thing happened with data transfer object. You can use for communicate between REST application and your application with your entity and your database. But remember, more layers, more attentions, more work, more time to handle that. Of course, my time is almost over. It's impossible to cover the whole world of database persistence layer in 45 minutes. there is a huge amount of information that I cannot cover here, like how to handle with transactions, linked transactions, metrics, configurations, how to handle with legacy modernization, fixed cache size, data grids, the classic problem with N plus one, right? I mean, who doesn't face it? This kind of issue. The frameworks, how to handle with different kind of frameworks, generics, reflections, GraalVM, native image, and so on. Connection pools, different kind of database, how to handle that with cloud and no cloud, on-premise, and so on. So it's a huge universe, but I only have 4 minutes left. And as call to action, if you want to know more, I wrote a book about the persistence layer with Karina Varela, and where we cover all the topics with more time. So if you want to know more about database, go for it. If you want to know more about NoSQL, go for it. This book covers the whole details that naturally I cannot cover in, again, only 45 minutes. Hopefully you enjoy this presentation, and that is all for today. Let's see if there is any question. If not, I don't have the link to slide. Let's do it in person. If there is no questions, okay, let's repeat the question. It's about eventual persistence and how to handle that. And each one I prefer, right? Eventual persistence first is the issue that we do have because the cap theorem. So right now I can have a strong and consistency and availability, but I cannot have consistency, availability, fault tolerance. Eventual persistence is one way to skip that. Okay, I'll make it available as possible, but I don't have the consistency, the information on the commit time. The sample that I showed to you, we do have Cassandra, for example. That is a sample of eventual persistence. So this data eventually become updated, especially if you do have like 10, 20 database, you're gonna take more time to update all the database with that. We do also have ScyllaDB that handle with eventual persistence. That is in key value database, we do have one that is React. As far as I know, it's eventual persistence, even as key value. But in NoSQL world, we also have the one that work strong with consistency. For example, MongoDB, you can do consistency. And right now, after version 4, we do have transaction as well. So you can explore that as much as possible. I mean, once you did a question, I have a book for you. So you can come here and take it. Is there any more question?
Yeah, we got a few questions.
Oh my gosh.
Do them starting here, and in perfect case, you read them out loud.
Okay, I can do it loud. Okay, how about use Eclipse Store instead of database? What do you think? Do you consider such a possibility? Yes, it's a good possibility to use Eclipse Store. Who is not familiar with Eclipse Store? There is a booth over there. So it's super great. You can try. Right now, what I do have in my experience is combine Eclipse Store with a database. Perhaps in the future, I can use only Eclipse Store. Right now, I'm combining, especially to use as cache and anything like this. So I have the consistency to the analytics on my database, and my to fast processment, I do have the Eclipse Store. Okay. Yes, you can answer the slide after. There was one question about the slide. And okay, it's a good question. What's the difference between data access object and repository? The data access object centralizes the database operation. You can see that by the method's name. For example, data access object should have insert, update, delete, and things like that. Repository belongs to the DDD by Eric Evans. That means it might be more abstracted methods. For example, save. This way, you do have any idea about the operation that you're gonna do. So it's more domain-centric way. So you can do the find by, and you have no idea about the query that's going on there. So if you want to know more about repository, there is the Spring Data that provides an excellent interface. And of course, right now we do have a specification in the Java world that is called Jakarta Data, where you can read the specification, give us feedback about that, and start to see the future of the Java enterprise with that specification. And no further questions. Thank you all again. So, and see you soon.